Hi there, this is Dr. C. Sonia, Assistant Professor in Chemistry, SNS College of Technology. As a continuation of the previous video about alloys, we are going to see about the types of stainless steels. So there are two main types of stainless steels. One is the heat treatable stainless steel and the non-heat treatable stainless steel. First we are going to see about heat treatable stainless steel. The composition of these steels, they mainly contain up to 1.2% of carbon and less than 12 to 16% of chromium. The properties, they are heat treatable stainless steels are magnetic, tough and can be worked in cold condition. And the uses are, they can be used up to 800 degrees centigrade. They are very good resistance towards weather and water. They are used in making surgical instruments, scissors, blades, etc. Non-heat treatable stainless steels. These steels possess less strength at high temperature. They are more resistant to corrosion. Types of non-heat treatable stainless steels. So according to their composition, they are of two types. One is the magnetic type. The composition, it contains 12 to 22 percentage of chromium and 0.35 percentage of carbon. Properties. It can be forged, rolled and machined by the use of a specifically designed tools. It resists corrosion better than the heat treatable stainless steels. And the uses of these types of steels are it is used in making chemical equipments and automobile parts. Non-magnetic type, the composition is it contains 18 to 26 percentage of chromium, 8 to 21 percentage of nickel, and 0.15 percentage of carbon. Total percentage of chromium and the nickel in such steel is more than 23 percentage. Stainless steel, if the steel contains 18% chromium and 8% nickel, it is refers to as 18 by 8 stainless steel. It is the most widely used stainless steel. Properties. It exhibits maximum resistance to corrosion resistance of which can be further increased by adding a little quantity of molybdenum. Uses. It is used in making household utensils, sinks, dental and surgical instruments. So heat treatment of the steel alloys, it's an important topic to be discussed over here. Heat treatment is defined as the process of heating and cooling of the solid steel article under carefully controlled condition. During heat treatment, certain physical properties are altered without altering its chemical composition. What is the objectives of heat treatment or the purpose of heat treatment? So heat treatment causes improvement in magnetic and electrical properties, refinement of the grain structure, removal of the imprisoned trapped gases, removal of internal stresses, improves fatigue and corrosion resistance. Types of heat treatments of alloy, steel. Okay, the main characteristics and the relevant heat treatment processes are annealing, hardening, tempering, normalizing, carburizing, and nitriding. Now let us see one by one. First is annealing. So annealing means softening. This is done by heating the metal up to a very high temperature followed by slow cooling in a furnace. What's the purpose? It increases the machinability. It also removes the imprisoned gases that is present inside steel. So there are different types of annealing. So according to the temperature that is used, low temperature annealing, high temperature annealing, low temperature annealing, it involves the heating of the steel to a temperature below the lower critical temperature. So what's the purpose? It improves the machinability, it increases the ductility, it reduces the hardness. High temperature annealing or it's the full annealing, okay? It involves the heating of the steel to a temperature of about 30 to 50 degrees centigrades, that is higher above the critical value. So mild steel 840 to 870 degrees centigrade. Medium carbon steel, the temperature is between 780 to 840 degrees centigrade. High carbon steel is from 760 to 780 degrees centigrades. So the purpose we know, that is the ductility and machinability. It makes steel softer. Hardening or quenching is the next one. It's the process of heating the steel beyond the critical temperature and suddenly cooling it either in oil or the brine water or some other fluid. So hardening, as the name says, it increases the hardness of the steel. Purpose, it increases its resistance to wear, ability to cut other metals in strength, but steel becomes extra brittle. It increases the abrasion resistance so that it can be used for making cutting tools. And next thing is the tempering. It's a process of heating the already hardened steel to a temperature lower than its hardening temperature and then cooling it slowly. Okay, so we have to see that the cooling process is done slowly over here. So thus for retaining strength and hardness, reheating temperature should not exceed 400 degrees centigrades. For developing better ductility, the reheating temperature should be within 400 to 600 degrees centigrades. Purpose, it removes any stress and strain, it reduces the brittleness and also some hardness. Cutting tools like blades, cutters require tempering. Next is the normalizing. It's the process of heating steel to a definite temperature, that is above its high critical temperature, and allowing it to cool gradually in the air. So what's the purpose of this? It recovers the homogeneity of the steel structure, it refines grains, it removes the internal stresses, it increases the toughness. Normalized steel is suitable for use in engineering works. Next is carburizing. The mild steel article is taken in a cast iron box containing small pieces of charcoal, that is the carbon material. It is then heated to about 900 to 950 degrees centigrade and allowed to keep it as such for a sufficient time so that the carbon is absorbed to the required depth. So that after that, this article is then allowed to cool within the iron box itself. So the outer skin of the article is converted into high carbon steel containing about something about zero point 0.8 to 1.2 percentage carbon. So what's the purpose of this? It's hard bearing surface on steel article. Nitriding. So nitriding is a process of heating the metal alloy in the presence of ammonia. Okay. So at a temperature of about 550 degrees centigrade, the nitrogen obtained by the dissociation of ammonia combines with the surface of the alloy to form hard nitride. What's the purpose? It's to get super hard surface.